Hello everyone. I would like to start this video by wishing everybody a very happy Christmas and a prosperous New Year. This video is part of the festive tech calendar 2024, where many of the technical people, they are sharing their knowledge as part of the festivities going around. Let's get started. And today we are going to talk about how to improve Kubernetes debugging with k8sGPT. Before we get started, a brief introduction about myself. My name is Nilesh Gule. I've been a Microsoft MVP since 2018, and I've also been recognized by Docker as a Docker captain for my community contributions. I like the game of cricket when I'm not thinking or talking about technology. I've put the social media handles here in case anybody would like to connect with me after watching this video, and if you have any questions regarding what I'm demonstrating in this particular session. So for the purpose of the video, I'm going to use an application called as TechTalks application, which consists of multiple components. It has a user interface, which is built using React. And then there are two microservices. One is called the TechTalks producer and a TechTalks consumer. Think of this as an application for managing technical events. And we are using a distributed application runtime called as Dapper, which helps us to communicate or which helps us to abstract many of the cross-cutting concerns and things like messaging. For the messaging layer, we are using RabbitMQ. And as part of this particular application capabilities, or to demonstrate different capabilities of the application, I'm also using a polyglot programming model where I've developed this application as part of one of the series I did on my YouTube channel. It's called as a Cloud Native Ninja, where I use different programming languages to demonstrate how we can start building applications, containerize the application using different programming languages like .NET, Java, Go, Rust, and use this with this distributed application runtime called Dapper. So in a very simple analogy, or in a very simple context, this particular application produces a certain number of events or messages, like a tech talk events. You can think of them like a series of events being published into the queue. And then there is a consumer which consumes these queues. So we will use this as a demo application and see how this works in the k8sGPT world, or how we can use k8sGPT. So let's get started by looking at the Tech Talks demo. And here I have run some commands. I've deployed this application on a Kubernetes cluster. And if you look at the output of the couple of commands I have ran beforehand, there is this kubectl get nodes, which tells us that I have 3 nodes running in my Kubernetes cluster. And I have some pods running. One of them is the RabbitMQ pod. Everything is deployed within the Kubernetes cluster in this particular example. This has been running for 96 minutes. And then there is the RabbitMQ producer deployment, which is running for more than 40 days. But if you look at the status here, it shows that there is a problem with this particular RabbitMQ producer deployment. It is having some issues with the image pull backoff, or the problem that it's facing is image pull backoff. If you have worked with Kubernetes, we know that this is one of the problems which comes when there is some issue with the container image that we are using. Now I will switch back to the presentation for a while and talk about different things which are involved in debugging Kubernetes. Now this particular iceberg shows different layers or different components in a typical Kubernetes ecosystem. If we start from the top, there is this Docker or a container runtime where we can containerize the application. And I feel that it is very easy to start with the top 2 layers, where we create containers, where we package our application as a container image. We create pods, we create deployments. We use things like ingress, secrets, configuration maps, and we expose this using a service. This is pretty simple, I would say, in the current context, and it is very easy to get started with this. As we go down this stack, this is where the complexity increases as we start adding things like custom resources, as we start doing stateful things with our Kubernetes cluster, like using persistent volumes and persistent volume claims, as we use stateful sets for running, let's say, databases, as we use init containers to initialize some of the things, and going down that other stacks, as and when we add more components, or as and when we add more ecosystem tools from the Kubernetes ecosystem, the complexity of the application and the blast radius keeps on increases, and it becomes quite challenging to manage this in a production like environment. Now, let's say if we were to debug the problem that we are facing currently in our application with the image pullback off, we would probably start with this. Now, this workflow talks about what happens in a very simple Kubernetes debugging when your application, which is deployed as let's say using a deployment in Kubernetes and then exposing it as a service, how would you go about identifying what is the root cause of a problem? Now, this might be the workflow might be slightly bigger on a screen, so I will split it into two, and let's see how do we probably go about looking at the issues. We would start by looking at the pods. That is what I did by listing the pods using kubectl get pods command. Once we identify that one of the pod is having an issue, we would look at the state, like is it in pending state? If it is yes, then we would go and look at a specific pod, giving the name of the pod, and then identify is there an issue with the cluster? Is the cluster full and it does not have enough resources? Then we might look at things like resource limit. If the cluster is not full and there are enough resources for us to schedule this particular pod, then we would look at the next things, like is the pod running? If it is not running, then we might look at the logs. If it is running, then we might look at describing and looking at is the pod in the ready state, looking at the readiness probes and things like that, and so on and so forth. By eliminating one possibility, we look at the next stage in the life cycle of the pod and see where the problem could be. Now imagine that the pod is fine, but then your service is having a problem. That is where the next stage in the debugging comes, where we start looking at options like port forwarding, then looking at the ingress configuration, fixing things on the service side in terms of the selectors and all those things. Now, this is for a very simple case, I say, because this is one of the most common thing that we do when we start deploying application onto the Kubernetes cluster by using one of these high-level constructs like a deployment or a stateful set, and then using services to expose them. And as I was saying, it is not just about these objects. As we add more and more capabilities to our application, we start using more and more systems or applications, tools from the Kubernetes ecosystem. This is where I would like to bring attention to the CNCF landscape, where CNCF publishes a list of projects and tools and services which are available in the whole ecosystem of the cloud native world. And if we look at the applications and databases, we can see there are a lot of projects listed here. Same way, things around CI/CD, streaming, messaging, there are multiple projects. Then in this landscape of security and compliance, automation, registry management, networking, runtimes, we have this whole list of projects. And then in terms of the scheduling, service mesh, observability, chaos, optimization. Now what happens with this is, in a typical project, we would use more than one of these projects. And when the problem happens, we would be then looking at possible solutions and root causes to identify in these different sections. This is where k8sGPT comes very handy. k8sGPT is an open source project which works with Kubernetes, and it uses generative AI to get helpful tips as well as to diagnose the problem and give us a possible solution. So the best way to get started with k8sGPT is to install k8sGPT and then look at what are the capabilities of the tool. If you want to understand how to install, I would suggest head over to the k8sGPT.ai page and head over to the docs and look at how to get started now. I'm using a Mac operating system, so this has a homebrew package which can be used to install k8sGPT. If you are on Windows, it's a similar process. We can download the binaries and we can configure it in the path. I've done a YouTube video on my channel for this particular setup of k8sGPT, and later in this video I will share the links how to get started. Now, assuming that k8sGPT is installed and it's configured correctly, when I run the k8sGPT help command, we can see here that it has these available top level commands at our disposal. It has the analyze command, it has the auth command, cache, completion, custom analyzer, filters, generate, integration, serve, and version. These are different top level commands which it supports. Now let's start by looking at the first one, which is the authorization. k8sGPT uses multiple backends, and these are the supported backend when it can configure or it can use for generative AI. If we look at the output of k8sGPT auth list, which will list all the supported backends, we see that Azure OpenAI is the default option configured in my current setup. And I also have local AI as the active provider. I've configured the large language model using LM Studio or Ollama. You can use different options, and if you want to use a large language model which is running locally on your system, that can be configured as one of the providers. So I have done those steps. I have already configured the Azure OpenAI as well as a local AI provider. And then there are unused models or unused backends, which can be like Ollama, Cohere, Amazon Bedrock, Amazon SageMaker, Google, NoPI, Hugging Face, the Oracle Cloud Infrastructure, IBM Watson, and Google Vertex AI. All these are supported. Again, if you want to know how to use this, I suggest head over to the docs, and in the docs, there is the getting started option, which will tell us how to configure and how to authenticate with the different AI providers. So based on the type of the provider, the setup or the way to configure that would vary based on what backend we want to use. Now, assuming that I have already configured the backend provider I want to use, and I have set the default provider, which is in this case, the Azure OpenAI, I can start analyzing the Kubernetes cluster. I can say k8sGPT analyze, or I can say analyze, ZE or SE. These are aliases and they both do the same thing. Now, when I run this command, it will analyze my Kubernetes cluster and it will tell me what are the different problems which exist. And it says here that AI provider is not used, and we need to use this explain flag. We will get to that in a while. But when I run the analyze command, we can see that it tells us that there is a problem with the pod in this particular deployment, RabbitMQ producer, and it is trying to pull the Nilesh Kule Tech Talks producer go_1 as the image, and it is having image back of pulling image problem or back of pulling image error. And same way, there are other problems with the cube system, extension agent matrix, and extension operator matrix. Now, we might say that there are other tools which are capable of doing this, which just list what are the problems in the Kubernetes cluster. The beauty of using the generative AI with k8sGPT is it can explain us what is the problem. So that is where we can use this k8sGPT analyze. And this time I am using the explain flag and asking k8sGPT to explain me what is the problem. Not just list the problem, but give me why that problem is happening and if it knows what's the possible solution for that. So now we can see when we use the explain flag, it's giving us a lot of options, or it is giving us the explanation in the natural language. And we can see it along with the first two lines which were shown earlier when we were not using the explain flag. It gives us this explanation saying it's an error, we have the Kubernetes cluster is unable to pull the image. It gives the image name and the tag for the application, and it also gives us the solution saying verify if the image repository and the tag are correct. Then it also tells us to check the network connectivity to the image registry or repository. Ensure image pull secrets are correctly configured. If you are using a private registry, authenticate with appropriate credentials. Now, these are all the steps that we would typically do if we were manually identifying this root cause of the problem and then trying to fix it. So we can clearly see that k8sGPT is able to identify what's the problem, and it's giving us a possible solution with step-by-step instructions what needs to be done to fix this problem. The first three problems are related to the same issue, because there are 3 replicas of that TechTalks producer running in my cluster, and the issue is same with all the 3 replicas. If we go into the other ones, it will tell us again what's the problem with Dapper system and Dapper monitoring. In this case, the service does not have any endpoint with the expected label, and it is telling us how to fix this by ensuring that the label is correct and it's added to the right service. The same way for the other problems, it will tell us, like in case of the extension agent matrix service, what is missing and what could be the solution. So that's a good beginning where we know what the problems are with our Kubernetes cluster and how to fix them. Now, it might so happen that there are multiple problems and we don't want to look at all of them in one go. And there might also be situations where how do we know what are the different kinds of problems k8sGPT can identify? So that is where we can use this command k8sGPT filters and list all the filters. Filters is an way or is the capability within k8sGPT to assign different types of filters. We can see what are the active filters in this list here, starting with a pod, deployment, ingress, persistent volume claim, service, mutating webhooks configuration, replica set, validating webhook configuration, node, cron job, and stateful set. This means that these are all the active filters in the default configuration of k8sGPT. And every time we run the analyze and explain command, k8sGPT is going to run its set of rules and different processes related to these active filters to identify if there is any problem with this. Along with this, out of the box, there are unused filters related to the horizontal pod autoscaler, pod disruption budget, network policy, log, gateway class, gateway, and HTTP route. If we are using any of these Kubernetes objects in our Kubernetes cluster, we can activate these filters and we can enable these filters so that they are also scanned. And if there are any issues with these Kubernetes objects, we can identify them as part of the k8sGPT analysis. Now let's try to use one of these filters. In our application, we know that we have problems with the pod. So if I were to list only the options for pod, I don't want to look at the other type of objects. I can say analyze and explain only the issues related to the pod. In this case, we can see that it gives us the problems which are only related to the RabbitMQ producer deployment, and it does not show all the other things that we were seeing in the earlier output. Now with this, I can go next step where apart from just explaining, I can also ask it to explain it in a language which I am comfortable with. When we are working with technology, not everybody is using English as a native language, and it could be difficult for people who don't use English as a native language to interpret this and to act on it. So the good part of k8sGPT is it can translate this into different languages. So if I go back to k8sGPT and we look at the top level commands, let's look at k8sGPT analyze and the top level command or the help for this command. We can see these are the different flags which can be passed to the explain command or to the analyze command. Explain is what we have seen so far. Filter is also what we have seen. There is a language option, and it uses language for the AI explanation or AI translation. The current languages which are supported are English, Spanish, French, German, Italian, and various others. Default is English if we don't specify anything. Let's try to use, let's say, one of these supported languages. I will use French because I know a bit of French. My French is very minimal or at a very basic level. And when I say explain this to me in French language, we can see here that the error and the solution is now given in French. So instead of giving me the output in English, the error still shows here in the default case, or when it is listing, it still shows it in English, but then it translates it into French for easier understanding of a French speaking person, and the solution is also given in French. We can also try this with one of the other language, like let's say Spanish in this case, and we will see the output in Spanish now. So this is, in my opinion, a very handy feature where people who don't speak English as their first language, they can still make use of the language translation capabilities of k8sGPT. Now we have looked at how to analyze the results, how to filter the results, and how to translate these results. Along with this, one of the benefit of the generative AI or large language models is that it can understand the questions, or it can use the context to give us the explanation in simple language. So here, what I want to do is, when I run the analyze and the explain command, I also want to run it in an interactive manner. And when I run it in interactive manner, I would be given like all those options first, saying these are the different errors. But then I also get into like a interactive mode here, or a prompt mode. If you want to close this, we can close by saying exit, and it will stop the interactive mode. Now in the interactive mode, let me ask a very simple questions like how many issues are related to tech talks. And we can see here that I have some typos here, or spelling mistakes. How many issues? It's not spelled correctly, the issue, as well as the tech talks has a typo or a spelling mistake in that. But the k8sGPT is able to understand that I'm asking how many issues are there, and it's also able to understand that I want to understand issues related to something which is called as tech talks. Now my application is called as tech talks in this case. So it tells me that there are 4 issues, and I can say, okay, give me details about the second issue. Because it has that context now, it can still go and look at all those issues, and it says the second issue mentioned in the context is related to the pod named RabbitMQ deployment. The error message states that there is error pulling image, and it will give me the suggested solution. So this way, if I have a lot of issues in my cluster, I don't have to look at them one by one. I can go into the interactive mode, and I can start asking these kind of questions in the natural language, and I will get a solution, or I will get the response again back in the natural language. Now I want to stop this, so I can write the stop command, and it will come out of this, or sorry, it should be exit. So once I press the exit, or once I submit exit as the prompt, it will come out of that. One of the questions which comes when I talk about the k8sGPT is, how does it handle the security? If my cluster contains some sensitive information, is there any way I can make sure that because I'm using a third-party backend, like Azure OpenAI is one of the supported backend here, or if I'm using, let's say, Amazon or Google backend for my k8sGPT, how do I make sure that the sensitive information is not sent over to the backend provider? So for this kind of use cases, k8sGPT has support for anonymization, and I can run this command which says anonymize, and in the explain and the analyze command, I can say, again, for simplicity, I'm going to filter only the pods here, and I can pass this anonymize flag. So in this case, if there are any secrets, or if there is any information which is sensitive information in my cluster, it would not be passed to the backend provider. I can also switch between the backend providers. When I'm running the command k8sGPT, as I was showing earlier, if we look at the auth and the list of providers, the authorization provider, we have configured local AI as one of the option here. If I don't want to use Azure OpenAI as my default provider and I want to switch to a different provider here, I can pass the provider flag and I can say k8sGPT analyze, explain, and along with the explain command, or whatever command I want to use, I can say I want to use local AI as the provider here. It's the backend flag. So yeah, in this case, I'm using the local AI as the backend, and in the output, we can see here that it is using AI provider as the local AI. So that way, we can switch between the different providers which are configured, and we can also set the default provider. If we don't set, or if we don't provide the backend flag in the analyze or the explain command, it would use the default provider. But when we specify the specific backend, it would use that backend to do the analysis and give us the output in the natural language. So with that, we have seen how k8sGPT can help us to identify the problem, to scan the Kubernetes cluster for different types of filters or different types of native Kubernetes objects, and then also provide us a solution. And it can help us to translate, it can help us to anonymize the data, it can help us to switch between the different providers. Now with this, these are all these features which come out of the box. And these are related to the things which are part of the Kubernetes ecosystem or Kubernetes manifest itself. When we create the default Kubernetes objects or different types of objects which are Kubernetes based. But what if we are using additional resources or projects which are outside of the vanilla Kubernetes? For that reason, k8sGPT supports the concept of what we call as the integrations. And there are different integrations which are supported. Let's list all the integrations that are currently available. As of this recording, there is support for Trivy, Prometheus, AWS, KEDA, and Kyverno. So by using these integrations, we can extend the capabilities of k8sGPT and use third-party products and services to scan and analyze them. Let's look at Trivy, which is one of the open source scanner for identifying any vulnerabilities in the Kubernetes cluster. So I'm going to enable the integration for Trivy. So the command for that is k8sGPT integration activate and Trivy. So when I activate the Trivy integration, it is going to create certain number of custom resources or CRDs within the Kubernetes cluster, which are required for scanning the Trivy objects. And now if I go and list k8sGPT, the filters, we will see there are certain filters added as part of Trivy. So there is this vulnerability report which comes from the integration. We can see that it is listed in a different color. On my screen, it's a light blue color. And same way, there is this config audit report, which is coming from integration, which means that Trivy has added these two filters in the list of available filters. Now, if I go and run the k8sGPT analyze command, and I say explain. In the earlier case, we were seeing around 14 or 15 issues. Now, what happens here is it takes some time for some of those Trivy integrations to activate. So I have to run this explain command multiple times, and after a while, we will see that it starts to give us the results. So don't be surprised if we see these kind of errors saying there is concurrent map read and all these things. I've seen in the past that after we run the explain command 3 or 4 times, it starts working. Looks like it takes a bit of time for some of these objects to be created in the background. So with this, what we would be able to see now is there are 78 issues identified, which means that the Trivy scanner has identified additional 60 plus issues, and we will see them in the list once the analysis is completed. I could have used the filter here saying just filter the 2 types of objects which are related to Trivy. And first time usually it takes a bit of time because there is no caching available. Once the results are available, once we scan the cluster and we have the same type of issue, the next time we run the same command, the cache comes into the picture, and usually we see that the explanations, they are served much quicker. So let's give it a few seconds. We are about 30 issues remaining in the scanning. Should be fine. We should get there very soon. Okay, so we have the list of all the issues analyzed, and let's go down. Let's skip the first few issues which we have already seen. But here, when it comes to the Trivy, we can see these are the Trivy scans. The issue number 9 in this case now is vulnerability report in the Dapper system. There is this replica set Dapper monitoring matrix deployment, which has a vulnerability. It gives us the CV number, which is a publicly available information in the database where these CVs are listed. It tells us what is the risk level, saying it is critical. And then what is the root cause? It will give us the things like this vulnerability refers to a critical security flaw that has been discovered in the system. Without specific details about the vulnerability, it is not possible to identify the exact root cause of this. And what is the solution? So it says update the software, monitor for official advisories, and implement security best practices. So this is the next level where outside of the Kubernetes objects, we are using an integration with Trivy, and using a Trivy scanner, it is able to identify these security related issues. So same way, we can enable the other integrations based on what is currently supported, like KDA, for example, or Prometheus, and we can scan the objects which are part of the KDA and Prometheus, which are created within the Kubernetes cluster. So with that, we have covered most of the things that I wanted to cover as part of this live demonstration. Let's go and quickly recap what did we achieve using k8sGPT. So a quick summary of the different backends that are supported. OpenAI is the default backend, and I'm using Azure OpenAI, which is a managed service where we can get access to the different OpenAI models. There is also Ollama, there is the Amazon Bedrock, Google Cohere, SageMaker, the generative AI from Oracle. Hugging Face contains a lot of open source models, so we can use those. Noop AI is there, Watson. So these are the different backend providers which can be configured very easily with k8sGPT. Again, I suggest look at the documentation for the specific step which is required to integrate one of these backends if you're interested in integrating with them. Then we looked at the filters which are provided out of the box, like the replica set, node, pod, cron job, and the others which are listed on the screen here. And there are also filters which are not enabled by default, like the gateway, HTTP route, horizontal pod, autoscaler, but these can be easily activated if the Kubernetes cluster that we are working with is using one of these type of the Kubernetes object. Then in terms of the integration, we looked at the Trivy scanner from Aqua, which is for scanning the open source vulnerabilities. There is also support for Prometheus, Kyverno, KDA, and AWS. And again, it's a simple command to activate and deactivate these integrations with k8sGPT. So in summary, what we looked at is how k8sGPT can help to improve the debugging experience when it comes to Kubernetes cluster by scanning for different issues and also providing a possible solution in natural language. It's a big plus for me when we can use k8sGPT to do this instead of running the commands ourselves and trying to identify where the problem comes from. If someone can do that and explain the problem to us, I think in a very complex environment like Kubernetes, it is a very handy feature. It supports multiple backends, which we covered just now, and it also has these integrations which allow us to extend the external tools and services. We looked at just one of them, which is the Aqua. Now, there are things which are very handy, but I have not covered them as part of this demo. But if you're interested, you can also look at things like remote caching. This is very helpful when k8sGPT is used in an enterprise environment, and instead of sending the tokens to the provider every time we run the scan or analyze command, for the frequently accessed information and data, we can use remote caching. We can use things like Azure Blob Storage or S3 bucket to store that frequently accessed information and improve the performance of the scanned result. This could be very handy, like when I was running the scan for the first time when we enabled the Trivy. Now imagine that there are 3 or 4 people trying to do the same thing. It could help to improve the performance if we cache those results somewhere. And in terms of automating k8sGPT related activities, there is a support for Kubernetes operator. In our case, I showed all the commands locally running on my computer, but then from an automation point of view, it would be very easy if we can run this periodically on a Kubernetes cluster and we can get those results analyzed automatically. That is where this Kubernetes operator comes in handy, and we can write the output of this into a Prometheus and then use a dashboard to visualize how different issues are progressing over a period of time. Again, very handy feature in terms of automating and improving the overall end-to-end process when it comes to diagnosing problems with the Kubernetes. So with that, I would like to conclude this session and give some references in case you would like to learn more about k8sGPT. You can head over to the k8sGPT .ai website and the doc section. There is also a GitHub page which talks about the different options available and the project, how it has different features and capabilities. I had talked about the landscape in the CNCF, so if you are interested in knowing about those projects, you can head over to landscape.cncf.io. And then on my YouTube channel, I have done multiple videos about how to integrate Azure OpenAI service with k8sGPT, how to use LM Studio to run offline large language models, and then how to integrate that with k8sGPT, how to set up k8sGPT on Azure, for example, and how to use Olama and other local options to run the large language models. And then I've done also a video on the k8sGPT operator part. So hopefully you will find these resources useful in your learning journey if you want to understand more about k8sGPT. These are my social media handles again. If you would like to know more about myself and would like to connect with me, please feel free to use these resources. And the source code and the slides for this are available on SlideShare, and the GitHub repository is Cloud Native Ninja, where I have the whole project for the Tech Talks producer, consumer, and other services I'm using. Thank you for watching this video. Again, this is part of the festive tech calendar, and once again I take this opportunity to wish all of you a very happy Merry Christmas and a New Year. Enjoy the festive season and use this as an opportunity to learn something new. I hope you found it useful. Thanks for watching this. If you have any questions, feel free to drop me a note. Thank you.